Hello guys, can you hear me? Hello, can you hear me?
Yes, sir.
Okay. Like 5 minutes ago, there was a power cut, so I'm connecting through my phone. So anyway, let's see. Probably it will come back during the lecture. If it comes back before my battery dies, then it should be okay. So today we are going to talk about image recognition, how image recognition can be used in sensory evaluation aspects. Okay. So for this, we are going to use a programming language. So the programming language we are going to use is Python. Guys, just give me a minute, okay? So we are going to use, basically today's, what we are going to do is, I'm going to give you a brief introduction to Python, okay? And then we are going to create an app using which we can do some image recognition, okay? Although we do image recognition using that app, it can be extended to any other length that you want. Once you understand the basic concepts, those concepts can be very easily extended. Okay, so those who are interested can study a little bit more, and I mean, in other words, actually, so right now there are like 5 research students who are working on these type of projects with me. And, you know, under these COVID-19 conditions, if you select that sort of a project, you don't even have to work with the instruments. You can even complete your research project while you're at home, because only thing you need is computer to do the project. I mean, the applications of this image recognition and machine learning and deep learning, those concepts, applications are becoming more and more like diverse in many fields. Now these concepts are being applied. So, for example, automatic recognition of ripeness of foods, like how ripe a particular food is, that can be identified automatically. And some diseases, plant diseases, by analyzing the leaves of the plants, that has been done all over the world. But in Sri Lanka, still it is a sort of a novel field. Not many researchers are doing that sort of research. So there is still some room, still some space to discover, okay, in like according to Sri Lankan standards, because there is a lot more to be discovered. But all around the world, so many people are using these techniques. So within these couple of hours, I'm just going to give you a brief idea. Okay. So we will start with some language basics of Python. So we can do this in two ways. Like one way is you can install, you can go through a bunch of installs. You can download from the internet and then install that software. But the other one is there are platforms online that are available online in which all the software that you need have been already installed. So like there is this really nice platform called Google Colabs. Okay, Google Colab. So that one has so many, like all the Python packages, libraries you need have been already installed. So that is the one we are going to use. But I did a trial run just before the class actually of what I'm going to do today with you guys. But I came to know there are some problems. Like there are some version mismatches. The problem is with the Python developers, like the people who develop Python and keep things updated, and the people at Google. People at Google, they have the latest versions. And the people at Python, they have they should be the people who should be having the latest versions, but their versions are like slightly outdated. So sometimes there are version mismatches. Okay. So that is something that I experienced today. So anyways, we are going to go to that Google Colabs platform and start working. So I will I don't know how strong this connection is going to be, but we'll just try, okay? So what you have to do is just go to Google and type okay. Okay, Google Colabs. Can you guys see my? Oh, I didn't share the screen. Can you see my screen now?
Yes, sir.
Okay, so what you have to do is just go to Google and type this Google Colabs. Colab, doesn't matter. Google Colab. Okay. Can you see that? What I have typed here? Can you?
Yes, sir.
Okay, so just press enter, and so the very first result that you get is the one that we are going to use. So there are like some prerequisites. Like I think most of you these days have Gmail accounts. So that is a minor assumption that I have made. So that is, I think, something that you require in order to create like files here. You most probably need a Google account. So I think you guys have Google accounts. So in order to access this, probably you will need to be logged into Google, like Gmail or something like that. Okay. Oh, so are you guys having any problems with that? So I just have to basically click on this link. Okay, just click on that. Then I will be presented with this interface. Okay. Then what we are going to do is this, we are going to click on this new notebook because we are going to create a new notebook. Okay. So did you guys come up to this point? Like, are you guys following me what I'm doing? Are you seeing this interface on your screen? Hello? Hello? Can somebody answer? So did you guys come up to this point?
Yes, sir.
Okay. So then we have to just click on this new notebook, a new notebook. Then it will quickly create a new notebook for us. I sincerely hope like we will have electricity, but I'm not sure. Yeah. If my laptop dies before that, it will be a problem. So here we can practice. I mean, right now it says untitled, so you can change that name to anything that you want. Any name, you can give any name here. So just say, let's say image recognition. Oh, no, this is just Python practice, right? So you can say Python. Or just Python essential. So just a minute. So then you can start like the very first thing you can most of the time in any crash course, you might want to print something to the screen. Print something to the screen. So print something like you want to print something. The keyword is print. Keyword is print, and then you have the parentheses open and close. Then just type whatever you want to be displayed on the screen. You can say anything like hello. Okay. Then when you want to execute, you just press shift and enter together. Shift and enter. Okay. So the very first time, it will take some time. Because it has to connect and everything. But after that, it will be much faster. Okay. So this is the environment. Like you will see how much RAM you have and how much disk space is available to you freely. Okay. So print. Now you know how to print something to the screen. Okay. And the other one is like there is a concept called comment. Okay. Comment. So what I meant was a comment. So comments are required in order to remind you what you have been doing. Like for example, if you are doing something complex, right now, because you have focus about what you are doing, you will understand each and every step and why you are doing that. But after some time, after like a couple of months, when you return to your work, when you go through what you have done 2-3 months ago, you probably will not remember why you did those things. So you can't just remember. So these comments, the purpose of adding comments is to give you some reminders why you did that. And you start a comment, single line comment with a pound sign, or what you say hash sign. Okay. So you can type anything you want. Like yeah, just type this is comment. Okay, so there is this think of Python interpreter. Python interpreter. So the Python interpreter is the software, or is the program that goes through each and every line that we type, and then it converts it into a machine readable form and executes line by line. So it is done by Python interpreter, converting our this English form, like this is written in English. So because the computer doesn't understand these English letters, it only understands ones and zeros. So all these lines that we type have to be converted into ones and zeros. It is done by Python interpreter, and those lines are executed then after that. But a comment, when it comes across a comment, the Python interpreter ignores those comments. Okay, so that is, ignores it's a comment. How does it identify? By looking at this pound sign, which is a pound sign here. That means it knows that line should be ignored. It's a comment. Okay. And if you want to put a multi-line comment, you start like this, 3 quotation marks, 3 of them. Okay. Then you can type whatever you want, like this is a multi-line comment. Multi-line comment. Okay, so this is a multi-line comment. So all these lines, like, they will be ignored. Okay. All of these. Okay. So when you want to execute something, you just say Shift Enter. Then it will go to a new cell. Okay. Okay. So then the next concept is variables. So variables are certain regions in computer memory to which we can assign different values. Okay, different values. For example, variables usually can have X, the very, like the most popular variable, X. Okay. So you can assign different values, like you can say X assign 10. So that means, so after you assign 10, the value 10 to X, you can, if you just press enter, it will go to the next line. Okay, it will not get executed, it will go to the next line. So you can say print X, then it will print the value of X. Okay. So after assigning a value to a variable, you can reassign a new value as well. You can say X assign 5. And then if you print X, the value will be different. First it's 10, then it's 5. So you can assign different values. Okay. So you can even assign multiple values at the same time. You can say X, comma, Y, comma, Z, assign 5, 10, 15. Okay. So you assign 3 values. You assign 3 values to 3 variables at the same time. Okay. So those are variables. And you can even, so this, in programming languages, especially in Python, this equal sign here does not mean equality. It means assignment, not equality. Okay. Assign means you just attach that value to that X. I hope you guys understand. So you just temporarily assign this value to x. X is like a box. At one time you can put 10. Later, if you put 5, that 10 disappears. Now it is 5. It's like that. So it's not okay. Okay, the electricity returns. So I guess we are not that unlucky. So guys, we'll have to find a different time slot and it will be a problem. There's this TV going on. Give me a second. Okay. Okay. Now, we were talking about these variables. Now, what is the difference between assignment and equality? Now, this is just, did you guys understand my description about assignment, the difference between assignment and equality? Equality is a logical thing. Equality is logical. Like somebody says like X is equal to Y. It is either true or false. Okay. But this assignment is not a logical thing. It's just like you assign something. Keep this value temporarily with you. Keep this value temporarily with you. Something like that. You just give X this value 10. Okay. So another thing is like you guys. So now still the router is not up yet. Okay, now the router is up. So we might be temporarily offline for a couple of seconds till we switch from this network to this network. I hope it will not be a big breakdown. Okay, I'm just going to connect to this one. Hello, can you guys see my screen? Hello?
Yes, sir.
Okay, so everything is back to normal. So we can say things like X assign X plus 1. Okay, X assign X plus 1. So if this is equal, if this is equality, then we cannot say that. Then this would be like something really wrong with this, right? So that is why I said this is not equality in programming. This is assignment. Otherwise, there is no meaning if somebody says X is equal to X plus 1. So this just says increase the value of X, increase the current value of X by 1 and assign it back to X. So if the current value is 5, increase it by 1, that means make it 6 and assign it back to X. That means X's new value is 6. Previous value was 5. Okay. So we can just say like this. Now if we say print X, now it's going to be 6. Previously it was 5. Okay. So did you guys understand the difference? Oh, there's a question. Is it okay to use PyCharm? Yeah. If you are familiar with PyCharm, so the thing is like, so there is a question, is it okay to use PyCharm? So PyCharm is a IDE, or what you call integrated development environment. But the thing is, you have to install everything. So the reason I use this Google Colab is you don't have to go through the trouble of installing everything, but actually you should be familiar with installing things. Okay, but thing is like different students have different familiarity levels with working with computers. So I just wanted to abstract that layer and make it easy for you, so that everything is already installed. But yeah, working with PyCharm is that's really good. Okay, so that's something that you can do. So are you guys okay with what I did up to now? Is it okay? Are you guys following? Are there any questions? Anything that is unclear? I can make it clearer for you. Or else now we talked about how to print something to the screen. How to print something to the screen. We talked about single line comments, multi-line comments, what are variables, difference between a variable and the equality sign. Okay, how to increment a variable, how to assign values to multiple variables at the same time. Okay, so we discussed a couple of concepts now. Now another very important concept, like guys, hello, yeah.
Why there are two things as the single line comments and multiple line comments? Are there any use in those two? Are there any differences when it comes to execution?
Yeah, the thing is like, now for if this was implemented as a single line comment, then for each of these lines you have to type this sign. Now let's say you have like a 15 line comment, 15 line comment or 20 line comment, then you have to type this one for at the beginning of each and every one of those lines. You understand?
Okay, sir, got it, sir.
Yeah. So now when you're using multi-line, you just have to type this at the beginning and this at the end. So it just saves time. Okay. So functions are really important. Now you know about variables. Variables, having knowledge about variables is extremely important in any programming language. And then we come to the concept of functions. So functions, the importance of having functions is reusing the code. Reusing the code without writing the same thing again and again. Okay. So it's like, let's take some analogy. Like, it's like you build some tool. You build some tool and then you safely keep it away so that you can use it again at some other time. But every time you start doing some task, you have to start building that tool again and again, then that's a problem, right? Once you build the tool that you want, you should be able to reuse it without building that again and again every time you need it. So that is the importance of functions. A function is a reusable piece of code that you define only once and then keep using whenever you need it, rather than redefining the same thing again and again. Let's say you want to find the third power of a number. That means the cube of a number. Tungani bale, the third power. In one word, we say cube of a number. So the cube of 2 means 2 times 2 times 2. Okay, so cube of 2 is 8. So cube of 4 is 64. Likewise, you want to calculate the cube of a number. Although we can easily find out the cube of the cubes of very small numbers. When it comes to big numbers, we can't just straight away calculate it using our head, like straight away. Okay, so we might want to create a tool for that. Okay, let's say we call that tool. We can give any name we want. Let's say we call it cube. That's pretty straightforward, right? We call it cube. So how do you define this function? So in Python, you have to use the keyword def to define the function, def. So the name you picked is cube. So then comes the name. Now, how do you calculate the cube of a number? What do you need? To calculate the cube of a number, you need a number. Okay? The first thing you need is a number. So you give this guy a number. Okay? Because if we don't give any number to cube, what is it going to cube? There is nothing to cube. First you have to give a number for it to cube. Then whenever you define a function, that function definition should end with a colon in Python. The function definition should end with a colon. So that's about it. Now, when you press enter, can you see I started from this point, but when I press enter, there is some indentation. There is some indentation to my right side. That is because of this colon. Now the Python programming language, the Python interpreter knows that I am about to define the function called cube. That is why this indentation is given. So what are we going to do? We are going to return the cube of a number. We have to return the cube of a number. So when you want to return something, we use the keyword return. So what are we going to return? The cube of a number. So how do you find the cube of a number? Number times number times the number. That's how you find the cube of a number. So this is just a very simple function. You accept a number, then you multiply it by itself 3 times and then return it to whoever asked for this tool. You return this number to that person, whoever asked for this service. Okay? You are given a number. Your task is to multiply it by itself 3 times. After you have done it, you just return. Here you are. This is the cube. You return that value. Okay? So that is the function definition. Now, how are you going to use it? So you can just call it by its name. What is the name? Cube. So let's say you want to print the cube of some number. So you put it inside print and you say any number, like you can say, let's start with something small so that we know it's working correct. So if you put 2, then the output should be 8, right? Yeah. Okay. So if we print the cube of, let's say, 5, the output should be 125, right? Okay. Now we go big and see whether it's working. So we can use some huge number. Say something like this. So just gives us the answer. So if you are not sure whether it's correct, then you can just type here just to check whether this is working correctly or not. You can just type it in Google and see the cube of this. So that is the answer. The cube of that number is that. Okay. So actually in Python, when you want to find the power of some number, you don't have to just write it like this. You don't have to write it 3 times like this. You can say number to the power 3. You can just do it like that. This I did for just for the simplicity. The same thing can be written like this. So this 2 asterisks mean to the power. To the power. So we can do the same thing. Okay. So that is how you implement a function. Are you guys okay with that? What I did? Are there any questions? Anything that you don't understand? See, you define once and then you reuse it multiple times. So that is the use of a function. Okay. Let's say I want to find the okay, the exponential, some exponential value, like some exponent. The base, there is the base, then there is the exponent. The base can vary and the exponent can vary. So there are 2 variables. So let's say you want to find 8 to the power 5, 9 to the power 6, 15 to the power 18. Likewise, both of them can vary. The base can vary and the exponent can vary. Padaya and saha balaya, both of them can vary. Padaya, that is base. Balaya, that is exponent. Both of them can vary. So how do we find something, define function for that? For example, so you can say, now you are going to define a function. So you can give any name you want. You can say base to power or anything. Okay. Okay. So now you need 2 numbers. You need a base and you need an exponent. And even these names, they can be changed. Okay, you don't have to call it base. If you don't like it to be called base, then you can use any other name. But always make sure that the names that you provide are meaningful. Okay. So how do we calculate this? We can say return base to some power of exponent. That's it. That is just a function. So you can now calculate anything you want, like any power now. You can say base to power. So you want to calculate the 11th power of 15. Okay, 11th power of 15. So that's going to be a big number. Okay. So see the power of functions. Okay. Okay. Now the other one. Now are you guys okay with the functions? We are going to go to the next step. Is the control structures. Now here, like we can even using these Python notebooks that are like what we are using, you can add even text. See, you can say like insert like text cell, okay? So add text cell. So we can say that one was added here, right? Okay, we can say printing to the screen. Okay, printing to the screen. And then we can just move the cell up. Keep moving it up. So now this is printing to the screen. Okay. And then I think you can even probably duplicate this or copy this there. Okay. And then you can paste them somewhere here. Like, so this is, you can just paste them here. Okay, now this is the section about comments. Yeah, this one, let's talk a little bit. Okay. So that is about comments. So likewise, you can add names to each and every section. Okay, to separate them. And now we can go to control structures. So we are going to do a control structure. Okay. Yeah, so we are going to add a text cell here and say control structures. So first we will try actually conditional statements. Conditional statements. Okay. Conditional statements. Conditional statements means things like if else. Okay. So let's say there are like two numbers, U and B. So U and B, one is U is 10, B is 100. Okay. U is 10 and B is 100. Yes. Yeah. Now, if you want to check, let's say you don't know the value of U and B. You want to check whether like which one is bigger and which one is smaller. You can say, you say an if statement. If you can say U is equal to V, if U is equal to V, you can say print U and V are equal. Okay. And then else if. Now, else if, I want to say else if, but in Python, else if has been combined as elif. Elif means else if, but that has been shortened as elif. So elif, U is greater than V. If U is, now if U is equal to V, we write print U and V are equal. Else if U is greater than V, we write print U is greater than V. Then finally we say else. I mean, there are only three cases, right? either they are equal, if either the u is greater than v, or else u is smaller than v. So you can say print u is smaller than v. So now you're done. You just press Shift Enter. Says u is smaller than v because u is 10 and v is 100. But if you say u is also 100, then after you change it, you have to run this cell again. Okay, run that cell again, and then you run this. Now it says u and v are equal. Okay. Or else you can say u is 1000, v is 100. It says u is greater than v. So this is a conditional statement. Checks for these conditions. Checks for conditions. Do you guys understand? I guess okay with this. In defining what to print, do we have to use O? No, or is something else actually.
No, sir. What I meant was right. The double commas or the single one.
Okay. Yeah. There is some. Yeah, there is something like. So let's say you want to use multiple conditions. This is checking for like a single condition in this line. But say you don't care whether it's greater than or smaller than. You don't mind. You don't mind whether it's greater or smaller. Whether it's greater or smaller, it's okay for you. It's the same thing. But you want to check whether it's equal or not. So in that case, you can include smaller than line also here. So you can see something like this. So I'll just change this. I'll just copy this and paste it here. So let's say O. So here you can say U is not equal to, I mean, this is not really required because I mean, if this is not true, then definitely then U is not equal to V. But I'm just saying that you can combine multiple conditions using O. But in this case, you just put the whole thing inside one parenthesis. Okay. So you can say, now if you run this one, says U is not equal to V because now U is 1000, this is 100. Because if at least one of these is true, this O gate is true. But if you put N, then both of them have to be true. But you know, greater than and smaller than, both of them cannot be true at the same time. So that is just, it doesn't make any sense. So, but there are situations when AND is useful. Okay. So you can use OR, and even there are some other conditions. You can use those conditions to combine multiple logical checks. Do you understand that?
Yes, sir, but what I asked was like in the first one that you gave to print hello, you used this double comma thing. I don't know what it's called. So in here, but you are using only the single one. So is there any difference between that one?
Okay. Yeah. So it's like this. Now, if you start with single quotation, you have to end with single quotation. If you start with double quotation, you have to end with double quotation. So the quotation, the number of quotations you have should match. But you can't start with single quotes and end with double quotes. Do you understand? Single quotes, double quotes, both are okay. But single and double, you cannot, like if you put double quotes here, then it's wrong. Do you understand? Now if I put double quotes here at the very beginning, now it has double. If I put single quote here, then it will give me an error. See, syntax error. So if you start with double quotes, you have to end with double quotes as well. And if you start with single quotes, that's fine. But you have to end with single quotes as well. Do you understand now?
Yes, sir. Got it, sir. Thank you, sir.
Okay, yeah. So that is about the quotation marks. Now, this is how you check for conditions. Okay. You can check for single condition at a given time, or you can even check for multiple conditions at a given time. Okay. Another one very useful one is going through a list. Okay. That is a very like a frequent situation that we come across. You have to go through lists. For example, let's say you want to type the numbers between 1 and 20 or 1 and 1000. Okay. You want to write the numbers that can be divided by 3 that exist between 1 and 1000. Let's for the clarity of, to save some space, let's say between 1 and 100, all the numbers that can be divided by 3 between 1 and 100. So how are you going to do that? That is where we have the things called loops. Okay, so I'm going to add the text here. So here you can say, loops. Okay. So if you want to type numbers that can be divided by, so you can say, so there are 2 ways you can write loops, mainly two ways. One way is using while loop. Okay. So you can say, first you actually define a variable. Okay. First you define. Let's say the number that you are talking about starts from, so 1 and 3 now. So let's say, I think I will start it simple and then make it more complex. Let's just write some numbers between 1 and 10, let's say. Okay. So I will say y is 1. Y is 1. So while y is less than 101, less than 101, that means up to 100. Okay, less than 101, you want to print Actually, this is going to be a little too much. I mean, so it's going to print 100 numbers now. So that's going to take some space. Let's say 11. Okay. So print y. Print y. So then the other thing is we have to increment. We have to increase the value of y. So what are we going to say? We are going to say y is equal to y plus 1. Now this is not equal actually. Y assign y plus 1. Y assign y plus 1. So now if we do this, it is going to print the numbers from 1 to 10. Let's say. You see? 1 to 10. Now, if we want to check if they can be divided by 3, I mean, any number can be divided by 3, but what we are interested is divided by 3 completely without any remainder. Okay. So there is an operator that will check the remainder of something. So that operator is called the modulus operator. Okay, modulus operator checks for any remaining stuff. Like for example, if we divide 3 by 2, what is the remainder? Remainder is 1. Let's say if we divide 11 by 5. 11 by 5. What is the remainder? If we divide 11 by 5, what is the remainder? Anybody? If we divide 11 by 5, what is the remainder?
1.
Remainder is 1, right? Remainder is 1. So that is something we can check. Like for example, we can say 11 modulus. Modulus is this one. And then 5. Okay, so we can say print see that prints the remaining stuff. So if we say 13, the remainder is 3. So likewise, if a number can be completely divided by 3, then that means if after we divide by 3, the remainder should be 0. If it can be divided by 3 completely. So all we have to do is check whether the remainder is 0 or not. Okay. So we can put that condition here. So we can say, I'll just copy this here. So we can say, if y remainder after dividing by 3 is equal to 0. If this condition is true only, it will print. So we have to put this one. So we don't just print. We check for this condition and then print. If it is true only, we print it. So now we can even go to 101, because I mean there aren't many numbers like that. So if you do it, so you get these numbers. So those are the numbers that can be completely divided by 3. Okay. So the other way you can go through a list is using a for loop. Okay. For loop. For the way you use it is for I, for example, this I is any you can change I, you can give it any J, K or anything. So I just choose I for I in range. Okay. For I in range. Now you give your starting number and the ending number. Let's say starting number 1 Ending number 11. Ending number, you don't include the ending number. It has to be less than that. But you include the starting number. You include the starting number, but you don't include the ending number. So that means it will only print up to 10. Now if you do this, print I, it will print up to 10. So I in range 1 level. Okay. Do you understand this? Again, if you want to put that condition, you can put that condition here. Just like before. If you want to check for this condition, you can include it here. I mean, we'll remove this one. Now in this one, you don't have to say y assign y plus 1. The for loop takes care of increasing the number 1 by 1. Okay. So this one actually, oh no, this is should be I. Okay, should be I. 1 to 11. Oh, print I. Okay, so this is only between 1 and 11. So likewise, now you have an idea. We can even like by default the increment is by 1, but if you want to increment it by 2 by 2, we can do that. Okay, 2 by 2. So if you want to say print the numbers increasing 2 by 2, you can just put it like this. Then it will go 1, 3, 5, 7 like this. 2 by 2. If you increase it to 3, it will be 3 by 3. Okay. Now we will, I think, yeah, that is something. Other things, I think it's better to start with the activities. But there is one more thing I wanted to tell you guys. Okay. Okay. There is something called object-oriented programming. Okay. Object-oriented programming. So I wanted to talk about object-oriented programming as well a little bit. Okay. Just to give you an idea. Now let's say, let's take the humans. Like, I mean, object-oriented programming is a way of looking at the world. Okay, it's a way of looking at the world. So best example is, I think it would be us, humans. So according to the object-oriented programming perspective, anything can be categorized as a class. Like any objects can be categorized as classes. For example, all of us can be included under the class humans. Okay, humans or people. Then inside that class, there are individual people like person 1, person 2, person 3, person 4, likewise. So those individual instances of the class are known as objects. Individual instances of the class, they are known as objects. Okay. Are you guys following what I'm saying? Hello? So if humans are a class, then these individual people like person 1, person 2, person 3, person 4, then those are the objects. Let's say, let's take a object like a door or a window or a bench or a table. Let's take the doors that we have in our houses. So all the doors can be categorized under a class called doors. All the doors. So under that class doors, then there can be different instances of door, like door 1, door 2, door 3, door 4, like that. So those are known as objects. So I'll just give you an idea. So we all come under the class humans. And then there can be person 1, there can be person 2. So those are individual objects, but this is the class. Now these individual objects can have two things. Those are attributes and actions. Attributes means like person 1, that they can have skin color, some skin color, okay, some weight, okay, some height. So those are attributes. Those are things that you can measure about that person. Okay. And then there are things that the person can do, actions. So there are attributes and there are actions. Like for example, a person can run. A person can walk. Okay. So there are so many actions. Can shout. So those are actions. All of them are actions. So those are actions. So this way of looking at the world is known as object-oriented way of looking at the world, or object-oriented programming. So these are attributes, or sometimes called properties. Okay, properties. Okay, so skin color, weight, height, those are properties. These are actions. Okay. So even person 2 can have these things. The person 2 also has a skin color, weight, height. He can also run, walk, shout, like this. So are you guys following what I'm saying? So there can be a class, then there can be individual instances. Those are objects. Then those objects can have attributes as well as actions. Is everything okay up to now? And then, for example, if we take class doors, okay, so there can be door 1. Door 1 can have like a color, can also have a height, weight, thickness. It can have actions. It can have open, close, lock, unlock. So this type of categorization can include anything. Okay. So there are attributes, there are actions. Okay. That is object-oriented philosophy. Okay, so that type of programming can be done in Python. So I just wanted to give you that idea. Okay, so one of the benefits of object-oriented programming is the concept of inheritance. Okay, now this is for the last year students that I from the talk that I used. I'm just going to, yeah, this is something, this is an example. Okay, now for example, there can be a class called mother, and she has an attribute eye color brown, and there is another class father. Father has an attribute last name Amazing. Then there is a class called children, and then these children can inherit from the classes mother and father. Okay, and when you initialize, there is this attribute called first name. Now this first name is, it doesn't have to be coming from the mother or the father, but this, let's say eye color and the last name, they automatically inherit from parents. So the first name is unique. So when you are defining a new child, you just have to say the first name is this. Everything else, last name, eye color, although you don't define them, since you have specified that this child is inheriting from this class and this class, that child automatically get those attributes. Do you understand what I'm saying? Are you guys okay with what I'm saying? Are you confused or are you following what I'm saying? So this is the concept of inheritance. Okay, so this is going to end our discussion on this. Now we are going to get into some action. Okay, so that is all I'm going to talk about the language, because this is a crash course and I think I have already talked for about 1 hour now, more than 1 hour about the language. So we are going to stop here. Now we are going to build something. Okay, we are going to build something. So for that we actually need a tool. Okay, that tool is freely available. That tool is freely available, which you can actually, the installation procedure is given in my website. But you can just find the installation procedure online as well. It's just for clarity, so that I might forget after some time, I have added a web page for my website. Because after some time, I might forget. So let's see. Here, it's here. It's under GUI programming. Yeah, this page GUI builder installation. Page GUI builder installation. Okay. So for Windows, it's easy. Windows, you just have to just double click and keep on doing next likewise. Everything will be installed. But there is a requirement, you need this TCL T key. So just click on this. Now open in a new tab. So there is TCL. So this TCL, you have to install TCL. Just click on this and then just double click. Everything will be, just have to press next likewise. It will be installed. Okay, you don't have to do anything special. So you have to install this TCL. Okay. And the other one is this GUI builder, because for this GUI builder to work, you need this TCL. So it is found in SourceForge. So SourceForge, we have the latest version of, so it says here 617 downloads this week. So you can just download it here. It's again, just double click on the exe file and it's very easy. Okay. So that is the tool that we are going to use. I mean, I have already installed this tool in my laptop. So I will show you how you can use it. Okay. So I will just close this. So once you install it, you will have an icon like this, page. If you don't get that icon, just go to the folder where you installed and just send a shortcut to the desktop. Okay. So that is the icon that you have to click. When you double click that icon, it will open up like this. It will open up like this. So for the purpose of creating this GUI, we are going to create a GUI, okay? So we need a couple of buttons. Okay, so it's so easy. It's very easy. So here, everything is given here. Whatever you need is in this widget toolbar. So if you need a button, all you need to do is click on this button thing. It says here button, right? You click on that. Now you click wherever you want the button. Now let's say you want the button here. Now there is a button. Okay. And then we also need a text entry. So there's entry here, entry. So you click on entry. You click wherever you want, where you want the text entry. See, now there's a text entry. Now you can move it. You can move it like this. You can even increase, decrease the width likewise. So this is all done in Python, okay? So you can just drag this button to whatever the position you want. Okay. Now it says button here, but you don't want it to say button, right? I mean, that's just not what we want. We want to change the name. Okay. So I will just increase the size of the button a little bit. We want to increase, we want to change the name. So you first click on the button and then the attributes of the button are given here. You have to go to the, if you go down slowly, you can see this text, this attribute called text. It says button right now. So we want to change it. Okay. We want to change it. I mean, I told you guys, I created the trial version of what I'm going to do with you before this lecture. I tried everything so that to make sure that everything is working perfectly. So what we want to do is we want to have this browse for image. That is what we want to have. So we will paste it here. So it says browse for image. Okay. It says browse for image. And we also want to draw a picture, like, I mean, not draw a picture, load a picture here. So to load the picture, we need a canvas. So we click on this canvas and then we click wherever we want. So that's the canvas and we can drag it to wherever we want. Okay. Somewhere like here, I mean, anywhere you want. It's just, you can use the arrow keys to change the position. And we want to make it 100 by 100, pixels 100 by 100. So how do you change that? It is again changed here. It says width and height. You see, geometry, width and height. So right now it's 133.83. That is why it looks like a rectangle. We want to make it 100 by 100. So 100, 100 by 100. Okay. Now we have what we want. We can even change the position a little bit so that it comes to the center. Okay. And then we want another button. So we click on this button and then we click on where we want the button. Okay. And we want to drag it to make it like centered. Something like this. Okay, and we don't want it to be called button. So we change the name. We call it predict. Predict. That is the name we want. Okay. So, and also we want a label to which we can print something. So we have this label. Yeah. So we click on label. Then we click on wherever we want the label. So like here, for example. But we want to drag it like to the place where we want, to the center. Okay. Then we want to make it a little big. And we don't want it to be called label. I mean, we don't want anything on it, right? Okay. So we want to remove this label thing, okay? So label, we go down. It says label. Where does it say label? Oh, first you have to select this. So if I select it and then look for the term label. Here it says text is label. So we want to remove that. Now there is nothing. I mean, we know there is a text label here. It doesn't appear. Okay. But if we click here, then it will get selected. Okay. And this one, this new top level, we click on that. And we don't want it to be called new top level. So we change the name. Right now it says title is new top level. So we change it to anything we want. Like I will call it fruit recognizer. Okay. Or let's say any name. It's or say fruit ID. Whatever, just can go crazy. Do any name. Okay. Fruit ID. So it will change to fruit ID. Okay. So that's about it. We have created the interface we want. Now we want to save it. We want to save it. Now where are we going to save it? We will save it somewhere like okay. So I saved everything in the trial here. I will create another one. I will create something called new folder. I'll just put 2021 here. Okay. And I will save it inside that. And I will call this fruit ID. Fruit ID.tc. Okay. So that's a TCL file, but Then we are going to generate the Python file. It says gen Python. Gen Python. See gen Python here. So we click on that, gen Python. Then it says generate Python GUI. Okay. Generate Python GUI. So it has generated it already. So then we say save. We click on this save button here. Can you see the save button? Just right here. It's here. So it says save. Now where did it save it? It saved it to that same place. I mean, it should be inside this 2021. See, fruitid.py. That is the Python. Then we have to do one more thing. Generate support module. First we clicked on generate Python GUI. Then we click on generate support module. That's all we have to do. We already did this one. The other thing we have to do is generate support module. That's it. It's generated. Then we click save. Okay. Everything has been done. Okay. So now we can close this. So if you go into this 2021, you can see there is fruitid.py and fruitid support.py. Now you have created a GUI for our program. So we can just close this. We don't need this anymore. We just close this. Okay, now we go back to the this Colab thing. Okay, Google Colab. Oh, not this one. Actually, this one. Yeah, Python Essentials. That is the one we were working on, right? So actually now we need, now we know about this Python Essentials thing, right? So I will just change the name Python Essentials and Deep Learning. Okay, just change the name. Now, this deep learning, what is deep learning? Now, first we are going to implement it using neural networks. Okay, neural networks. Now, what is a neural network? First, we have to look at the very basic unit of a neural network. How did it get this name? So, there are some people, I mean, this neural network concept was obtained or borrowed from biology, from the concept of the neuron. So if you just Google for neuron, you can see neurons like this. I mean, there are like bunch of pictures. Just if you just click on images, there are so many images, right? So many images. So just pick any one of these, like this one. Now you can see the signals are coming this way from the dendrites. From the dendrites, the signals are coming. And then those signals are processed by the nucleus. Processing is done here. The signals, the inputs are received from the dendrites and the processing is done here. And the output is given through the axon. Output is given through the axon, through the synapse, to the next neuron, or to the next muscle cell. If it is the ending neuron, then the next muscle cell. But if it is another neuron, then the output is given to the other neuron. Okay. I think, I mean, you guys know this, like you are all biology students, you know the structure of a neuron, and like the dendrites are here, and then processing is done in the nucleus. The output is given out in the axon. You know this myelin sheath increases the speed of the output, so all that stuff. And there are neurotransmitters and acetylcholine and all that stuff. You have studied everything. Okay. So now what is the equivalent unit of neural networks for this neuron? That is the perceptron. Perceptron. Okay. So much time. What happened? Okay, it's here. Now this is the, previously we saw the neuron. This is the equivalent structure of the neuron in a neural network. The neural network, you have the inputs coming, and then there is a function that does some processing, and then there is an output. Okay, input, processing, output. Here also input, processing, output. So that is the equivalence. This is the neuron, this is the neural network, basic unit of the neural network. Now this basic unit of a neural network has a name known as the perceptron. Perceptron. Okay, that is the perceptron. So I can ask you in the exam, what is the equivalent unit in a neural network for a biological neuron? That is the perceptron. Okay, I think you guys can see what I have. Yes, the perceptron. But actual neural networks are more complex than this. Actual neural networks are more complex than this. Now here you see input layer, output layer, and a hidden layer. This is known as a hidden layer. Input, hidden, output. I mean, here actually there is no hidden layer in the perceptron. There is only input and output. This processing layer, this processing function is not really considered as a hidden layer. So this is just input and output. But I will show you. Now this is a single layer, but in actual neural networks there are multiple layers. There are multiple layers. So there are, if you just Google for multi-level neural networks. Okay, multi-level neural networks. You just check for those. Now you can see there are different levels. There is input layer. Output of that is given to another layer, which is the hidden layer 1. Hidden layer 1. And output of that hidden layer is given to another hidden layer. And output of that hidden layer is given to another hidden layer. And finally, from that hidden layer, it's given to a final output layer. So there are like many layers, but the basic structure is this. There is input, processing, and output. Input, some processing going on, and then output. That output becomes input to another layer, some processing, and some output. That output becomes input to another layer, some processing, and output. Likewise. Okay. So now you know the difference between a single level neural network and multi-level neural network. And that's the input, output, and in between you have the hidden layer 1, hidden layer 2, hidden layer 3, like that. So whatever is in between the input and the output layers, Those are hidden layers. Okay, hidden layers. Now, in a neural net, there are different types of neural networks. Now, the neural network that is relevant for image recognition is the convolutional neural network. Convolutional neural network. So that can be another question. Okay, convolutional neural network. So I will increase the font of this. Convolutional neural network. Okay. Now, you can see, I mean, this is a paper that I'm working on. So there are always these weights and biases. Now, those weights and biases, what are those weights and biases? Now you can see here, weight 1 bias, weight 2 bias. So those are some numbers that can be changed. Those are some numbers that can be changed. So the task of a neural network is to iteratively, that means round by round, it will improve the initial values of these weights and biases. It will improve the values of these weights and biases in an iterative manner. In an iterative manner, finally, until the whole network, neural network is optimized. The whole neural network is optimized. That is the task of a neural network. So at the very beginning, the values for these weight 1 bias, weight 2 bias, those are not good values. But after each iteration, the values are going to improve. So when you feed an image to a neural network, a convolutional neural network, it is going to identify certain patterns of the neural network, certain patterns. It is done through an operation known as a convolution. Okay, it is done through an operation known as a convolution. Now, you know that computers cannot identify images. Computers can only identify numbers. So the image has to be converted to a bunch of numbers. So although we see it as an image, for the computer, it is a bunch of ones and zeros. Bunch of ones and zeros. Then in a convolutional neural network, it has a filter. I mean, more than one filter. There are many filters. Those filters are looking for certain characteristics. Those filters are looking for certain characteristics. Now, there is a very nice, I will just go to this link, this number 10 resource. This one right here. If you click on this link, so it will open up a web page. Is it taking too much time? Like the machine got stuck a little bit. Perhaps I need to stop certain activities because I have opened too many windows. So I will close some of these to make it easy for the computer. Okay, now it is coming up. So this is a really good web page. You should check this one out. This is a really good one. So you can see now this is the image. This is an image. Now when I take this mouse hover the mouse over this image, you can see the numbers. Okay, those are numbers. Those numbers are between 0 and 1 and 255. Okay. So this is a black and white image. So it's like there is only one color channel. Okay, black and white image. For a color image, there are 3 color channels, usually the red, green, and blue. Now this is what you call a filter. This is a filter. Okay, this is a filter. Now these filters can look for certain patterns. Now this is a sharpening filter. If I apply this filter, this image will become sharp. Now, if we take this filter, now you can see this is a 3 by 3 matrix. It's a 3 by 3 matrix. If we take this filter over the image, can you see what it's doing? Now, it is at the top left-hand corner. Now, these values, the pixel values are 206, 205, 247, then 244. So those are the pixel values. Okay, and if it is a lower value, then it's more black in color. If it is a higher value, it's the black intensity is low and the white intensity is high. Okay, that is because it's a black and white image. Now, each of those pixels are multiplied by the values in this filter. So 206 is multiplied by 0. 205 is multiplied by -1. You can see those are the filter values. Filter values. So then it is going to add them up. Add them up. So you can see the answer in that case is 65. So it is going to convert by applying this filter. It is going to convert this image into the one on the right hand side. You can see that is a more sharp image, like sharper image. Okay. So if you apply a different filter, like this is sharpen, if you apply a different filter like blur, now the picture is blurred. So this is the blurring filter. These numbers have been found out, calculated by the experts who know how to create these filters. We don't have to worry about that. Those filters are already there. We just have to apply the correct filter. Okay. So there are filters for different tasks. Now this is the emboss. Okay. Now what I want to tell you was, like, there are filters that like this filters. When I say filter, what should come to your mind is that it is a mathematical, it's a matrix. Okay. So there are filters. When you apply those filters to an image, it can identify certain patterns in that image. Okay. So different filters identify different patterns. So that is the task of a neural network. So when you have only one hidden layer, for example, when you have only one hidden layer, the number of patterns identified, we can say it's a little less. But when you have multiple hidden layers and more filters, then you can identify very small, even minute patterns in the image. That is the task of a neural network, to identify certain patterns. The more filters you have, better you can identify the patterns. Okay, if you have only a very little number of filters and only one layer of one hidden layer, then the pattern recognition is not very good. But if you have multiple hidden layers with more filters, you can identify even very small patterns in the image. Okay, so that is the pattern recognition or the image recognition. So in Facebook, for example, once you upload an image and you tag a person, it identifies the facial features. It identifies your face. It creates a matrix for your face. Then next time when you upload an image, upload an image, guys, so I'm going to switch back to the other network. Okay, for the time being, let's keep it. Okay. So anyway, so if I upload a new image, that filter is going to be applied to the new image. Then if it comes across that same pattern, then it identifies your face in the new image as well. Okay. So that is done using filters and neural networks. Okay. Now there are different types of layers in a neural network. Different types of layers. Okay. Now the very first layer is the input layer. I mean, input layer is where you just input the image to the network. There is always an input layer and there is always an output layer. Okay. In between, you have different layers. Now this convolution, now you know what convolution is. Convolution is just this multiplying and adding. It is just matrix multiplication and addition. Okay, that is convolution. That is done in a separate layer, which is known as the convolutional layer. The convolutional layer identifies patterns using filters. That is done by the convolutional layer. Then there are other layers. Like we will come across different layers, and I will introduce you to different layers when I come to those different layers, without explaining everything right now. So we will go to Google Colab again. Okay, now we can create a new notebook. New notebook. Now this one I will call it ID 2021. Okay. Now we need certain packages, certain modules to be imported in order to carry out this analysis. So I have already run these things for you, like because before the class I tried these things. Now we need a bunch of packages. Okay, we need a bunch of packages. Everything has been installed in the Google Colab, so you don't have to install them. But there was a person at the very beginning, he asked me whether PyCharm can be used. Yes, now for that person who is using PyCharm, he can install this TensorFlow. TensorFlow library you have to install. So if you want to know how to install TensorFlow, I mean in the PyCharm, I think you can, yeah, I have PyCharm, but I'm not sure whether I can open that because I have too many things open right now. I think I installed PyCharm some time back, but yeah, let's just focus on this one. Are you there? The person who is using PyCharm, are you still there?
Hello, sir.
Yeah. Do you know how to install the new package, a new library?
Yes, okay. I know. It's
Yeah.
okay.
So yeah. So you just have to install this TensorFlow because now with the TensorFlow you automatically get this Keras package. This Keras package comes with TensorFlow. So when you install TensorFlow, you get all these Keras packages with it. And also you have to install the Seaborn, NumPy, Pandas, Matplotlib. This is like basically for plotting things. If you want to plot a graph, then Matplotlib can be used. Then you have Pandas, NumPy. So these are different packages you can use, and this pickle is for working with files. Zipping and unzipping, you have zip files. If you want to go across certain folder structures, like for example, create a folder, access the files inside the folder, then you have this OS. If you want to create certain paths for certain files, you have this path, this module. So like there was likewise there are certain packages or certain libraries you have to install. Now everything that we need is here. Okay, everything that we need is here. So all of this, if you just copy them, where is this? Yeah, this one here, and just control like so, Control V. Okay, then if you press Shift Enter, okay, now it is first going to allocate resources for me. It's connecting. Okay, it says connecting to Python 3 Google Compute Engine. Initializing. Then it will finally say connected. See, now it's connected. Okay. Now, so we have all the packages we want. And the next thing, now I have created a GitHub folder. I have created a GitHub folder for you to download certain files. Like this is the path for that, this HTTPS, this one here. So I will just copy and paste this command in the chat window. Okay, copy and paste this command in the chat window. So you can take this one. Okay, Now, when you run this thing, it is going to get the resources from this location. It's going to get this resources from this location, images and everything. So you just have to copy this thing and paste it here. Paste it right here. Okay. And then press Shift Enter. So it has already done that now. It brought everything from the GitHub. Now you can see what you imported here. You click on this and click on this right here, this folder, and go to this, because now you can see the location. This is in this temporary folder, TMP. You got this TMP. You can see this one, abo model.zip. That is what you just imported. Okay. But this exists as a zip file right now. Zip file. So we don't want it as a zip file. We want to unzip that. Okay. So the command to unzip that is right here in the next one. This command here. So it's basically access this zip file, abo model.zip, and then it extracts everything. Extracts everything to this TMP folder. Okay. So you just have to copy and paste it. Okay. Now, if you refresh this by clicking here, refresh this, now you can see this ABO model main, that is the extracted folder. Now you have a bunch of test images and train images. Okay. Now this everything else you can remove because you really don't need them right now. You can remove them. Because you don't work with them here. You just remove them. So I mean, one by one, we will remove them later. Otherwise, it will just take some time. Okay. Now, if we go to the next one, next thing what you have done is created a data directory. Okay. Now, this is the directory that contains all the data. That is why it is called the data directory. The name we have given is data dir. So we control C and then copy it. Okay. We place it here, paste it. We can just copy a bunch of them together. Okay. And then we can copy these ones as well. Now this will create the test path and a train path. Now you might be wondering like what is the test path and what is the train path. So I will talk We will talk about that. Now, when we are doing image recognition, there should be training data and test data. Training means your model has to be trained using some images. Then only it will train itself to identify something at a later time. So even in the Facebook face recognition, first it needs a couple of images to train the model, so that next time when a new image is uploaded, since it has been already trained from the previous images, it will correctly identify the face in the new image. So to do that, you need training images as well as test images. Why do you need test images? Test images are needed to test whether your model is correct or not. Training images are needed to train your model to identify the pattern you want. Testing images are there to check whether the model you have created is working properly or not. Okay. So you have to divide the content, divide the photos you have into two, to a training set and a test set. Okay. I think you understand what I'm saying. Because now it's like this. You cannot train using the test data, because training data is like this lectures. We are doing these lectures. These are the training data. This is to train you. But in the exam, there will be an exam paper. That is the test. If you have trained yourself very well now, then you can predict the answers correctly in the test. But I cannot show you the test paper now. Then there is no purpose in doing the test. It is the same thing here. You train the model first, and then you check whether the model is predicting correctly or not. So for that purpose, you need a test path and a train path. The test path contains your test data. Train path contains your train data. So after you have done that, you can press Shift Enter. Okay, that's it. And then you can check whether you have correctly connected to your test and training images. How do you check that? Just check for the individual image names. You check and see whether you can connect to them or not. You see, now there is an image name. That means you have correctly created the connection between this folder. Now this is from the, you click on this train, you can see there is apple, banana and orange. Now this is for the apple folder. Train path, that is train, then the apple folder. Under that, the very first image. Because under apple folder, there are many images. Okay, we are asking for the, like the very first one. You might be wondering, like, the very first is 166, but that is not how the Linux file system is working. So it is giving us this as the very first image. Okay. So the 0 is for the very first image, because the indexing starts from 0. 0, 1, 2, 3, likewise. Okay. That is how the indexing of images starts in Python. Starts from 0, not from 1. So similarly, you can check whether this image is correctly loading up on the screen. So first you give the image a name. You give the image a name. You call it train apple 1. train apple 1. Okay. And then you visualize. You try to visualize the. Now you can see here, the image is shown as a bunch of numbers. IM read, that means to read the image that is connected to train apple 1. You can see it's a bunch of numbers. But if you look at the exact image, it will show you an image, not a bunch of numbers. See? It's an image. And the shape of the image is, this is the shape of the image. 100 by 100 pixels. And what is this number 3? This number is 3 is for how many color channels are there? There are 3 color channels. Red color, green color, and blue color. Those are the 3 color channels. So that is for specifying the number of color channels. This is the number of pixels, 100 by 100 pixels. Okay. So these things I can ask in the exam. So the last time also, I think they didn't think that there will be a question from my this deep learning, but there will be a question. So if you don't study, if you don't ask questions and try to understand this properly, then you will find it quite difficult to answer the questions in the exam. Then you might not fail the exam because there is only one question from me. But if you manage to understand what I'm saying by asking questions, if you don't understand, then you might be able to save some points. Okay. So you can do a similar thing for other fruits as well. This is for the apples, and for the oranges also. You can find out the first. You can find out the image name of the very first image. For example, in the case of orange, again, the image name is this. Then you create a link to that. Create a link to that. So you first copy this one. Okay. Likewise. Then you create the link. First you run this. Actually, you can run this and see the name of the image is 199_100. Then you give a variable name to that. Then just like before, you visualize it. IM show stands for image show. Okay. So this is orange. Okay. So you can do a similar thing for the banana as well, which you can try by yourself. Okay. Otherwise, it will be very boring. Next thing is, now you try to check how many images are there. How many images are there in the training folders and how many images are there in the test folders. So in the training folders, there should be approximately same number of images for each class. So in this case, there are 3 classes, orange, apple, and banana. You have to have approximately the same number of images in each of the 3 classes. Otherwise, your training will not become accurate. Your training will be biased. For example, if you have only 50 images of orange and 500 images of apple, then your system is more likely to categorize a new fruit as an apple, because it was trained a lot for apples and trained for orange very little. So that is why, to remove that bias, you have to have approximately same number of images for each of the classes. So we have 3 classes and we have approximately the same number of images. Now this, what this code is doing is, it is going to this train path, that is the TMP ABO model, this whole thing, that is the path. Then it is going to this orange folder, because there are 3 folders, right? Apple, banana, and orange. So it goes to this orange folder. Then it is trying to find the length. Length means the total number of images. Return the number of items in the container. So in this case, we only have images. So it will return the total number of images in that folder. So the total number of images, we press Shift and Enter. So there are 561 images inside the orange folder, 577 images in the apple folder, 575 images in the banana folder. Okay. Similarly, you can check the number of images in the test folder as well. Okay. Then you are going to do something very important. That is, you are going to create an image data generator. Now this is done. This sort of image data generator, what it is doing is known as image augmentation. So I will tell you what image augmentation is. Now this is what is done by image augmentation. Now let's say you have an image like this. You have an image, but the number of images you have is very less. But you want to have more images. But you don't have that many images. So you are going to create many images using a single image. So you have 100 images, you want to make it look like 1000. You actually have only 100, but you want to make it look like you have 1000 images. So to do that, you can perform certain activities on this image. Like the very first one is random horizontal shift. That means horizontally, horizontal means tiras adat. It's horizontally, you randomly drag it to the left and to the right. So initially the parrot, this is in the middle, but now it is in the first one, it's in the left hand corner, right hand corner, in between. So you randomly shift it along the horizontal axis and you create 9 images. You had only 1, but now you have 9. Then you can random vertical shift. You shift it vertically as well. Now you have even more images. Okay. Now random zooming. This is zoomed in, zoomed out, again zoomed in. Now you have even more images. Now you are rotating. You rotate the parrot. Okay, you rotate the parrot randomly. Okay. and you have horizontal flip. Clockwise and anti-clockwise, you change the sides. So by doing these different activities, you can increase the number of images you have. That is the data augmentation. Data augmentation. So that is implemented here. Rotation range 20 degrees. Width shift range 0.1. Height shift range 0.1. So this is defining the limits for that kind of augmentation to increase the number of images. And it is also rescaling the images by dividing everything by 255. When we divide all the numbers, because all the numbers are between 1 and 255. When you divide them by 255, which is the maximum number, you can bring all the numbers between 0 and 1. You sort of transform all the numbers to the range between 0 and 1. Then it becomes very easy to work with those numbers. The calculations become faster. That is why you divide them, and also there is something known as normalization. So what this does is it is normalizing the images. So it brings all the numbers to a number range between 0 and 1 by dividing with 255. Do you guys understand what I'm saying here? Do you understand? Hello?
Yes, sir.
So if you find anything difficult, just let me know. Okay? You can go over it again until you understand. So this is what it does. So we can just press Shift Enter. So now we created the image generator that will do the augmentation. Okay. Now we are going to associate each and every, we have only two. We have the test folder and the train folder. We are going to connect the train folder and the test folder to this image generator, which is going to do the augmentation. So first one, image gen.flow from directory. From which directory? Test path. Test path we have already defined. That is at the very beginning. At the very beginning, we defined the test path and the train path here. So now we are going to connect those test path and the train path to this image generator for image augmentation. Okay, so we press Shift Enter. And then we do the same thing for the train path as well. Okay, that is for the train path. Now we are going to create the neural network. Okay, create the neural network. Actually, all these from TensorFlow, Keras, and everything has been imported at the very beginning. Okay, I have included all of that here. So everything that has to be imported has been already imported at the very beginning. So we can straight away just start creating the neural network. So this neural network is created in these lines. Just, I just copy these lines. Just paste them here. Now here we are creating the neural network. It is a sequential model. Sequential means you are sequentially adding layers to the neural network. So how do you specify that? We say model assigned sequential. Model is a variable. I introduced what variables are before. Now the sequential is a class. So you create a new object from the sequential class and then you assign the name model to that object. Now you need a bunch of classes for this. You need CONV, that is convolution 2D, because you are going to do a convolution. And you also need something known as max pool. That is something called pooling. I will describe what pooling is to you. So I asked in the last exam the meaning of max pooling. Okay, so there are different types of pooling. And there is average pooling and max pooling. So usually max pooling is done. So to do this convolution, we use CONV 2D, con 2D. How many filters? 32 filters. The size is 3 by 3. That is the filter size. Now I showed you guys before using this website. Now this is the filter, 3 by 3 filter. Now here they have shown you like 9 filters. Okay. Now here we are creating 32 filters. 32 filters. Each one is a 3 by 3 matrix. Okay. Input shape. We are giving the input shape. Now input shape is given here. 100 by 100 by 3. 100 pixels wide, 100 pixels in height, and 3 color channels. That is the image shape. And then activation. What is the activation? This is not going to that. Activation is ReLU. ReLU means rectified linear unit. Rectified linear unit is an activation function. Now, activation functions are a very important concept in neural networks. Okay. So I will explain to you here. Now this is the activation function. Activation function, without an activation function, a neural network can only identify linear features. Linear features, like in a given image, almost like many of the patterns are non-linear features. Many of the patterns are non-linear features. So to identify those non-linear features, we have to add activation functions. So the role of the activation function is to learn non-linear features. Okay. Non-linear means, like, for example, now if it is linear, it is something like y equals mx plus c. Y equals mx plus c, that is, it's a line. Now, let's say you have a feature, and that feature divides these two regions, this red region and the blue region. Okay, that feature divides this red region and the blue region into two regions. Can you do it with a straight line? What can you say, guys? Can you separate this blue area and the red area using a straight line? Can you do that?
No, sir.
Yeah, that is why we say it's a non-linear feature. Now that red, and in order to identify this red pattern and the blue pattern as two different patterns, you need a non-linear filter to make this boundary. So just if we just have theta naught plus theta 1 plus times x1, that is y equals mx plus c time, say c type of a line, then you can only draw a line like this. But as you can see, a simple line cannot separate these two regions. We need non-linear, like there are to the power 3, to the power 2. Now these are non-linear features. This non-linearity is introduced into the neural network via the activation functions. Okay, that is something that you have to keep in your mind. What is the use of applying activation functions? That is to differentiate between non-linear features, in this case in the given image. Okay. Now this rectified linear unit is something like this. I mean, this is the ReLU. This is a rectified linear unit function. This is the definition of rectified linear unit. Okay. For any other value less than 0, the value of ReLU is 0. For any value that is higher than 0, the value is equal to x. The value is equal to x. 0 for anything less than 0. Can you guys see this? Not sure. Can you guys see this one? For anything less than 0, value is 0. For anything greater than or equal to 0, the value is equal to x. This is the rectified linear unit. So this is the activation function that is used here, ReLU. Okay. And I didn't explain what pooling is yet. So pooling also is included in this paper. I have included description about pooling. So rather than yeah, this is pooling. Now try to understand this concept. Okay, it is very easy. Just have to pay some attention. It's nothing much. Now imagine this is your image. This is your image. Now you have divided this image into 4 matrices: the green one, red one, orange one, and the blue one. Now altogether, how many numbers are here? 16 numbers are here. Now for a given image, depending on the resolution of the image, there can be many pixels. There can be like billions, like, you know, the cameras that we have in our phones these days. We have like 48 like megapixels. So it's like megapixels, right? That's 10 to the power 6. So huge number of pixels. So you can imagine how high the resolution is. So this is just an image. We can't show 10 to the power 6 pixels here. No. So we are just showing 16. You can see pool size is 2 by 2. Pool size is 2 by 2. That means for pooling, we are using 2 by 2 matrices. 2 by 2 matrices. So it's just like this. It's a 2 by 2 matrix. Now in max pooling, in place of this 2 by 2 matrix, I am using the maximum value. So replacing all these 4 numbers, I am going to replace all these 4 numbers using the maximum number, that is 100. I replace these red, these are 4 numbers that are shown in red squares. I'm replacing those 4 numbers using the maximum number out of those 4 numbers, that is 184. Here all of them are equal to each other, so I can use 12. Here I can use 45. So that's it. That is max pooling. So what is it doing? It is downsampling the image. It is downsampling the image. That means I'm reducing the number of pixels. Downsampling. And what is the purpose of downsampling? What advantage do I get? The advantage is my calculation time decreases. Now I have to work with less numbers. Because I removed some numbers, I replaced some numbers. Like here I'm replacing 16 numbers with 4 numbers. In place of 16 numbers, I have now only 4 numbers. So that's like a 4 times decrease in numbers. Okay, and at the same time, I am maintaining the prominent features. Because I'm picking the largest number in that region. So if there is a prominent feature in that region, I am preserving that prominent feature as well. Another way of doing it is by calculating the average of the 4 numbers. So you calculate the average and then replace these 4 numbers by the average of those 4 numbers. Replace these 4 numbers by the average of those 4 numbers. Okay. So that is another way of pooling. So there is average pooling and also there is max pooling as well. Do you guys understand that?
So
Yes, sir.
question, when reducing the sample, does it affect the training so the quality is lowered?
Yeah, it can happen. It might happen because some images like because usually now these are factors we can tweak. Now, it's not like we are doing this only once and then accepting that as the final solution. If the outcome of this pooling is not good enough for our purposes, then we will readjust. We will readjust and change the numbers again so that we end up with the required accuracy. So if the model we create eventually is not up to the required accuracy, then we will come back to this stage and change the numbers, change the pool size and things like that. But if we can achieve the accuracy that we require, at the same time performing the max pooling as well, then we are saving speed as well as the accuracy, right? Do you understand?
Yes, sir. Thank you.
Yeah. So, and at the same time, now let's say, now there is a, now let's say there is a cat. Let's say there's a cat in the image. We are looking for a cat in the image. Now in the training images, the cat is in the center. But in the test images, the cat is in the corner. So will it identify the cat? Because we trained it for a cat in the middle of the picture. So in the test images, if it is the cat is in the left-hand side or the right-hand side, still we want the model to be successful, right? So by using this type of feature like this max pooling, what will it do? I mean, not only max pooling, the max pooling also contributes to that. Even if the image, even if the feature is in a edge of the image, we can still identify if it is prominent. Like when we replace this 4 with this 100, we can see that there is something in the left hand side. There is something not as big as 100, but something a little lower towards the bottom. So likewise, the computer understands, even if it is not in the center, what are the relative magnitudes of the features. So it does not have, something doesn't have to be always in the center for it to understand. Because if there is a image, if you upload an image of yours, let's say it's a group photo. In the group photo, and you have already uploaded some of your selfies. In the selfies, you are in the center. But in the group photo, you are in the left-hand corner. But still the Facebook will identify that you are in the image. Because of what is known as this translational invariance. Translational invariance means even, like, what is translation? Translation means uttarane. Uttarane, what is uttarane? Uttarane is translation. No, that's all. Translation means you move a figure along a line. Along a line, you move something. Even if you move an object along a line, still it will be able to identify. Translational invariance means that. So that is this max pooling. This certain tricks like max pooling, they contribute to translational invariance. Okay. I don't know. Do you guys understand what I'm saying? Did you understand what I said? I don't know. I hope you understood. So let's say, I think we have an image like that here. Show that it's there or not. Oh, yeah, something like this. Now, 8 is in the bottom now. But in our training image set, 8 was in the center. Without certain tricks like max pooling, the neural network will have no idea of saying that this is also 8. Because now it is not in the center. So that is the importance of translational invariance. Your model should be translationally invariant. Otherwise, it will not be able to identify. Now this is 8. Okay. And then there are, what else do we have in our model? In our model, we have convolutional layers, right? We talked about that. Convolutional layers. Max pooling layers. So right after a convolutional layer, we usually have a max pooling layer. So again, we have a convolution layer. Again, we have a max pooling layer. Then we have a flattened layer. What is a flattened layer? Flatten means you write all the numbers in one column. like not in like 3 rows. Likewise, you bring everything to one column, like you make all the data one dimension. That is flattening. You do this flattening before you are going from a max pooling or a convolutional layer to a dense layer. Before you go from either max pooling or convolutional layer to a dense layer, you have to flatten. That means you remove the dimensionality. You make the multidimensional data, you convert it into a one-dimensional data. That is flattening. Okay. So when you are flattening also, there is some information loss. Okay. And then there is dense layer. Now, what is a dense layer? You have to identify, like you have to remember what are these layers. Now you know what is the convolutional layer. You know what a max pooling layer is. You know what a flattening layer is. I mean, flattening is actually an operation. It's not a layer. It's an operation actually. So, and then there is dense layer. Dense means all the nodes are connected to all the other nodes. So what does that mean? I'll show you what it means. Now here, now this is a, here you can see. Let's take this node. No, let's take this node. This one right here. Now this node is connected to all the other nodes. Okay. Now a given node in a particular layer is connected to all the other nodes in the adjacent layers. Then that sort of a layer is a dense layer. Nodes in a layer that are connected to all the other nodes in the adjacent layers, they are known as dense layers. Okay. Now, if you take a node like this is connected to these two as well as these three. So it's a dense layer. Okay. Do you understand what dense layer is? Then finally, you have a, I mean, the very final one should be a dense layer. But before that, here you have a dropout layer. That is also another good one, dropout. What is dropout? Dropout is you randomly remove some connections. Randomly remove some connections in the neural network. What does that mean? Now you can see all these connections. It's like going all the way like here, 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 like this. But then there is randomly, you remove some of these connections and see how the model works. Now, how much do you remove? Here it says 0.5. That means 50% of the connections are randomly removed. 50% of the connections are randomly removed, and then you see how the model readjusts itself. If it is a good model, even if you randomly remove the connections, it will more or less reproduce the same accuracy. It will somehow recover. It will learn more successfully and produce the same accuracy. Do you understand what I'm saying? Now it's like this. In Sri Lanka, we have chemistry degrees in Sri Lanka. So in Sri Lankan chemistry degrees are world famous. If a person, for example, I mean, not only chemistry actually, but especially for chemistry, because we are working under very low facilities. We have very low facilities. Our instruments are not working. They are not up to date. We somehow managed to attach some wires and, with some tweaking here and there, somehow managed to get the instrument working. So if you somehow manage to learn chemistry under those conditions, then you will definitely be successful when you go abroad. Do you understand what I'm saying? Do you guys understand? Are you there? I don't know. Are you guys there? Are you guys listening, or have you guys gone out for tea or something? Okay. So that is what I'm saying. Now, if you can prosper under harsh conditions, then under right conditions, you will definitely be successful. That is the purpose of this dropout layer. It is making things difficult for the network by randomly removing the connections. Then see how the network recovers. Then even under these conditions, if the network can accurately identify the patterns, then the network is a really good one. Our model is really good. That is the purpose of a dropout layer. Now, there are some people like only if you provide all the facilities, then only that person can be successful. The moment you remove this comfortable chair and give him a very like a average chair, then he will complain. I can't do anything because now I don't have that chair anymore. Then it is not a successful model. That is not going to work. Okay. So, so I'm going to give you an idea. What is the meaning of this dropout layer? Now, there are some terms that you should know when somebody says a dropout layer. There are some terms that you need to use. Okay. Now, this is a dropout layer. Dropout layer does exactly what the name says, randomly severs connections. Okay. Dropout is done to overcome the problem of overfitting. Do you understand? That is to overcome overfitting. What is overfitting? Overfitting is like this. Now, you have past papers. Now, you study for past papers. Okay. Now, there are past papers. So, let's say you somehow manage to find past papers for the last 5 years. Okay, past papers for the last 5 years. But then there is a new lecturer. The lecturer changes. Lecturer changes, and you have practiced all the questions for all the questions in the last 5 years. You think you are the hot shot. In the exam, the new lecturer gives new type of questions. Now what will happen? If you are a talented student, you should still be able to somehow answer those questions as well, because they are from the syllabus. They are from the syllabus, but they are not the type of questions that were asked in the last 5 years, because those are from a different lecturer. There is a particular way a particular lecturer usually forms questions. It changes from lecturer to lecturer. But if you can only answer the questions from the previous lecturer and you cannot answer the questions from the new lecturer, that means you have overfitted yourself. Overfitted yourself for the past papers that were given by the previous lecturer. You haven't really learned the content, but you know how to answer those questions in the past papers. Learning how to answer questions in the past papers and really learning the content are two different things. If you really learn the content, it doesn't matter who asked the questions and what type of questions. You can still answer the questions if you have really learned. That is the purpose of dropout layer. It is going to check whether the model has really learned the content, or is it overfitting? Is it overly dependent on the data? That if you remove some of the data, it totally breaks down as a complete disaster. Is it the case, or has it really learned from the data? That is the purpose of adding dropout layers. Okay, do you guys understand what I say? Are you okay with that?
Yes, sir. Yes.
Okay, now you know all the, now you know the meaning of all these layers. You know what a convolution, convolutional layer, max pooling, average pooling, flattening, dense, dropout. You know what ReLU function means. You guys like, you know, almost everything now. Now then there is another activation function known as softmax. Softmax. Okay. Now softmax means you are calculating the probability. Okay, now I will show you. So there is a really nice, but it doesn't matter. I mean, you can just search for softmax. It's just have to type and see. This is here. This gives the formula. So this is the value of softmax input vector. It's basically calculating the probability for the output values. Like how much probability will be there to give an output like this. How much probability is there to give an output like output 1, output 2, output 3, output 4 like this. So let's say there are images of cars and images of vans. So the probability of the outcome being a car, probability of outcome being a van. Okay. So if, because there are sometimes if it is a Serena, okay, if the image is of a Serena, I don't know whether you guys, do you know there was a vehicle called Serena some time back. Have you guys heard of that?
Yes, sir.
Yeah. So if you have been given a picture of a Serena, then if you are looking from very like a large distance, you might have some trouble in differentiating whether it's a car or a van. Okay. Then it might predict like the 50% car, 30% van, something like that. Then depending on the those probability values, the softmax will choose the outcome with the highest probability. That means if it is 50% and 30%, it will go with the outcome with the higher probability. That is, it will go with the 50% outcome. That is the that is the main idea of softmax function. Softmax function is used when it is a multi-level classification. When it is a multi-level classification. So here it is a multi-level classification because we have 3 classes. Multi-level means more than 2. More than 2. If it is 2, then there is a different classification model. That is not softmax. It is called it's actually binomial. We call it that name. Anybody knows that name? There is categorical cross entropy versus. So any answers? categorical versus binary. So categorical versus binary. Okay. So binary cross entropy is for having two outcomes, yes or no type of outcomes. Okay. Categorical cross entropy is for three or more. It's not yes or no. It's like a, car, van, bus. You have to choose between those three vehicles, and so more than two options, more than two classes. That is categorical cross entropy, and you use softmax function in the output layer. And the other one is sigmoid. That is the word I was looking for. Sigmoid activation. Sigmoid activation function is for binary cross entropy. That means there are only two outcomes, 1, 0 type of outcomes. Then you use sigmoid activation in the output layer. But for more than two, you use the softmax activation layer in the output. So those are exam questions. Okay, what type of activation function is used in the output layer for a multi-level classification model? That is a direct exam question. The MCQ type question. Okay. Okay. Now we have come towards the end of this one. Okay, now we looked at dropout, we looked at softmax. Loss is categorical. That is how you look at the loss. Loss means in any given model, there is a way to look at the loss of accuracy. Loss of accuracy. So for multi-level classifications, the loss is measured using the quantity known as categorical cross entropy. And then there is a optimizer. So there is a model, there is a mathematical model to check whether it has reached your model has reached the optimum or not. That objective function is defined by this, whatever the name that is given here. Now, in this case, the optimization function is Adam. So you can check, like, what is this Adam? Adam is like somebody's name. So can there be a function like that is somebody's name? There's the Adam optimizer. See? Adam optimizer. Adam stands for this. Adam is a replacement optimization algorithm for stochastic gradient descent for so it's stochastic gradient descent. Stochastic means random. So I mean, this you can look at this like a stochastic gradient descent. What is this gradient descent? Gradient descent. There is gradient. What is gradient? Can you give me another name for gradient? Another name in mathematics for gradient? Gradient can single gradient can. What is the single name for gradient?
Slope.
Slope. Yeah, good. That's really good. So gradient just means slope. Now gradient descent. Descent means you are going down. Gradient descent means you are following the direction in which the gradient is decreasing. You are following the direction in which the gradient is decreasing. If you follow the direction where the gradient is decreasing, at one point you will come to a position where the gradient is like going through 0. That means you have reached the minimum. Okay. So that is, and if you are looking for a maximum, this should be gradient ascent. If you are looking for minimum, it's gradient descent. If it is maximum, it's gradient ascent. You know, using by calculus, dy by dx is 0 at a optimum, right? That is the basis of this gradient descent algorithm. It is looking for that point where the dy by dx is going through 0. And it is starting from a random value, it is stochastic. Okay. So this is the optimizer. Adam is a very popular optimization algorithm. Okay, that is the one we are using. Okay, and then there is metrics. Metrics means how are we going to measure our accuracy? We are using accuracy. There are, accuracy can be measured using different other methods. One of them is accuracy itself. But there are other metrics. Okay. Now, if we, I don't know whether we have disconnect. Yeah, we have disconnect. Not this. We have, I think, we have been disconnected. So we'll have to reconnect. Okay, now we are connected again. Now we can actually run this whole thing again. We can say run all. Okay, run all. It's going to run everything. Because after disconnection, it's better to run everything. Because otherwise, some of the commands might not be working. Now, yes, we have. Where is it now? Okay. Now we can start running our model. Can start running our model. How now we can also get a model summary, and model summary gives you an idea about how your model parameters look like. Okay. How many weights do you have? How many biases you have? Like number of parameters that it is optimizing. See, it is going to optimize so many parameters. That is why when you have many layers, optimization takes a long time. But our model, it's not that big, because we only have 3 classes. 3 classes. And this one is also a pretty cool concept. It's called early stopping. Early stopping means now we are going to run this model, but if the accuracy of the model does not change, like in this case, it is monitoring the validation loss. If the loss is not changing considerably for successive 4 steps, for 4 successive steps, if this validation loss quantity is not changing considerably, then the optimization is going to stop. Because if this validation loss is not changing considerably for 4 rounds, then that means the model has reached a most probably reached an optimum. Okay. 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 Train image gen. We did that one. And then we have test image gen. So here we are again associating our train image gen folder with the image generator and the test image gen folder with the image generator, where it is going to adjust our image shape if it is different into 100 by 100, and it is going to use the color mode red, green, blue, and the batch size is 16. That means it is going to read the images in chunks of 16. That is important if we have only very low random access memory, because if we have very low random access memory and if we try to read the whole thing in one chunk, then our computer will get stuck. So if we are quite low on RAM, it is better to read them batch by batch like this. Okay. So our class mode is categorical because we have more than 2 classes. And for the test images, we are not shuffling the images, because shuffling the images is done for the training images. Training images, after every iteration, we are shuffling the images. Because we assume that if we don't shuffle the images, the outcome will be biased. The outcome will be biased if we don't shuffle the images. That means our model will not be a well-trained model. But after our model has been trained properly, without any bias, under those shuffled conditions, then our test image set, we can predict accurately. But the test image set doesn't have to be shuffled. I mean, there is no meaning in doing that. That is why we say shuffle equals shuffle assign false for our test path. Okay. Then we get the indices. What are the indices? Like we have apple, banana, and orange. Usually in the alphabetical order, it assigns indices for each class. So A, that is the apple class, that is assigned the index 0, banana index 1, orange index 2. So these classes are indexed as 0, 1, and 2. Okay. And then, okay, now we are going to we are going to save the outcome as it is generated to a variable known as results. It is helpful for our later analysis. Okay. That is why we are saving the outcome as it is generated into a variable called results. Now we can start hopefully running the training. Now it says model.fit generate. Now we want to fit the training image, fit the model to the training images. Fit the model to the training images. This epochs. Epochs means how many times are we going through the whole training image set? How many times are we going through the whole training image set? So we are going to go through the whole training image set 20 times maximum. Okay, but it might not go 20 times if our early stopping criteria has been already met. Our early stopping criteria means if the validation loss does not change significantly for 4 successive rounds, then this criteria is satisfied, then the simulation, the optimization is going to stop. But the maximum we are going to allow it to continue is 20. Now we can start. Hopefully there is no error. Okay, now it has started training. See, now it is training. Now we will wait until it has trained. It will not take that much time. It will only take, I don't know, 3 minutes maybe. Do you have any questions in the meantime? If you have any questions, you can ask me. I mean, there are times where we can go watch a movie and come back and our model will still be training. But in our case, it will be done in a couple of minutes because it's a very simple one. We have only 3 classes and we have only few images, like about 1,500 images. But there are situations where they have like 10,000 or like million images, then it's going to take a lot longer. Then we will have to wait. We will have to wait, or we will have to use much better computers so that calculations will be faster. But in Sri Lanka, I mean, most of the time we don't have access to that sort of sophisticated computers, but we can always buy some computation time. We can buy some computation time for considerably less amount of money from people like Kaggle. There is this website called Kaggle.com. Kaggle. Okay. So Kaggle.com is a place if you want to be a data scientist. Now, data scientist is supposed to be the sexiest job in the 21st century. By the Harvard University, it is given as the sexiest job in the 21st century. Data scientist. Okay, and there is a very high demand. So if you want to be a data scientist, one of the websites that you should really visit is this Kaggle.com. Where like everything is free. Everything is free and there are so much data you can practice with. Free data. See, there is, if you click on these data sets, so many research groups have uploaded like thousands of data sets here. NBA, fatal encounters, tennis racket specifications, Olympics in Tokyo, latest COVID-19 deaths in India, stock exchange data. See, it's like this plant diseases, fruit and vegetable image recognition. There's like huge variety of data here. So you can pick any data set and start working on it. Everything is totally free of charge. And here they have some really nice computers. You can even start running some of your advanced algorithms here. If your laptop is not good enough, you can run it freely here. And there are some competitions. If you can take part in these competitions, and if you win, you can win some prizes, like you can win some money. See, this is $100,000. This is $30,000. This is $20,000. So if you just try and like somehow win this, if you win $100,000, you see, like come on, you don't have to do a job for a long time. You can just buy some laptops and start working from home. Now these are for knowledge only. They are not going to pay you. These are just for your knowledge. But here $50,000. You see. Okay. And for anybody who is interested, I think you guys are losing interest because now there are only 29 students. So at the beginning, there were like 41 students. So anyway, we will be only doing this for a few more minutes. I think maybe our calculation is already finished. Let's just check, okay? When is that? Oh, it's running. Oh no, it's finished. Oh no, it's still running. Still running. It's in the 10th epoch. Yeah, accuracy is like it's at the top. It will stop very soon. Most probably it will stop. What I was going to tell you was you can go to this YouTube. Okay. And there is this channel called Code Basics. Okay. Code Basics. That is some really nice channel. Everything is totally free, and there are some really nice playlists here if you want to be a data scientist. These videos, you should really go through these videos. See. Data science series, projects from end to end, how to face interviews like technology interviews and things like that. So many of these are available. Really important ones. So try this. I can send you some really useful links if you are interested. Some of you have already asked me for some links that they want to start a career in data science, and I have sent some important links to them as well. So if anybody is interested, now this is a really good channel. Okay. Okay, let's see. Is it still, oh, man, this is still running. But we are very close now. Extremely close. I'm surprised that it's still running. But maximum it can run is like 20 epochs, that's all. And now it's already at 14th epoch. And you can see it's going pretty fast. So what I was going to tell you was like, now this Google, these people, they have the latest versions of packages. And there is a package mismatch between what the packages that are available to be downloaded from the Python website, from the Python developers, and from the ones that are being used by the Google Colabs. And that is a problem, because the models that we generate from this Google Colab, once we download them and try to use them in our local environment, sometimes it says that there is a mismatch in the library versions. Then the only solution is to like install everything in your local computer and then generate the model using that computer. Then the problem with this Google Colab is, since they are using the latest libraries and the ones in our computer are not that updated, the generated outputs from the Colab cannot be opened using the ones that are in our computer. That is the problem. So I'm just going to show you up to that level, and then I will have to go back to my computer and start using the ones there. Now we can evaluate the accuracy, evaluate generator now. How accurate is our model? So that can be measured using this method, model.evaluate generator. It's going to tell you like how accurate your model is. It says here that the accuracy is 1. That means this one has like 100% accuracy. This is a simple model, so the 100% accuracy is there. But for other complex models, this can go down. Okay, don't expect always to have 100% accuracy. So now we are going to save the neural network. Now we have done the simulation, and now we have to save the outcome. We have to save the parameters that we optimize. Okay, now what are the parameters? We already came across that. Now this W1, W2, this B, now these are the parameters. Now our model has been optimized. Now we need to save these parameters. This model, this W values and B values, we have to save them. Now this is all about saving. Okay. So we can just copy this thing, whole thing, and bring it here. Now this first one is only for saving the structure of the model in the JSON format. That means JavaScript object notifier. That's a different model. It's a type of file. Okay, file format. JavaScript object notification. Okay. And then we can save weights of the model, those W values, separately using model.save weights. Then we can save both the skeleton or the structure of the model as well as the weights in one file using model.save. Okay, so we can give different names, like because I already have a file like this. Actually, it's okay. I will just run this. So it will save them. Now it has saved them already. Now if we go to that file, TMP folder, okay, TMP folder, it will have the data that we saved. It will have ABO model trial structure, this JSON file, which we can download. And then it has this trial weights, which we can download. And again, this whole model. So those outcomes can be readily download. So that is up to, we have to know up to that point how to work using the Google Colab. Okay, so this, all these things that we did using Google Colab can be done by installing all these packages in your laptop as well. Okay, and we can also, I mean, this is for this is some extra stuff. Now I'm going to show you. See what happens to the. I'm going to show you. Now they should be in the downloads. I mean, we downloaded them to the downloads folder, right? So again, stop a little bit. Let's see here in the downloads. I have too many things open. So here, these are the ones that we downloaded. So this 5.8, this file, and there should be another one. Yeah, this one. These three, we just now downloaded. Okay. And this same thing I have done using my local environment as well. And the same thing I did. All the commands. When you're running on your computer, you don't have to like really bring it from the outside because you have the data in your machine. You don't have to bring it from the GitHub. But if you want, you can. Then basically, so we did all this. We did this, created this model. Then we ran the optimization. Then we saved this JSON file, H5, and the total model. This is to check whether the accuracy and the loss. The loss was in this case like almost 0 all the time. Accuracy was also almost 1 all the time. But this is for this simple one, but most of the time it will not be like this because this accuracy will be very low at the beginning and it will increase as the number of epochs increase. Accuracy will be like this, going like this. It will increase and it will become stable after some time. And the loss, so here we have loss. So loss means in that case, loss should decrease. Accuracy should increase with epochs. Loss should decrease with epochs. Okay. Now we already have that GUI that we created. Can you guys remember? You already have this one. You have created that. And then what we have to do is connect these files that we generated using TensorFlow with this GUI model. So how can we do that? Now these files that we generated, those are here. So we generated this, this JSON file, this weights file, and this file. So these files that we generated, we can put them inside here. Okay. Now we have to do some changes. Now we just pasted them here, but we have to make the actual connection inside this Python file. So in order to do that, we have to open that file. I'm going to open it using Notepad++. Now this is how that fruit id.py, the Python file looks like. Okay, this is how it looks like. Now the very first thing you want to do is stop people from resizing this thing. So if you want people not to resize this, we have to this stop.resizable. This is by default 1, 1, it has to be changed to 0, 0. Okay. And then now, although we have added those buttons, we didn't create the connection, right? Now it is time to create the connection. Now this code should be added here. The code, because now what does it look like now? It looks like, now we can go to this place. And then we can say, open that file. Okay. Let's say Python fruit ID .py. Okay. Python fruit ID.py. So if you do it now, actually, yeah, even if you do it now, it looks like this, right? It looks like this. Now, if we click these buttons, nothing happens. Now we have to add some action for these buttons. Okay. So that is what we are going to do. We have to attach some action to these buttons. Now this one, when we click this button, it should open up a dialog box so that we can select the image that we want. So how can we do that? So we have to add the code for that. So what is the code that we are going to add? To open a dialog box. Now this is the code. I mean, I have already created that. I will explain what it does. Now it says load image, load image, file name assign FD box, ask open file name. Now you have seen, like when we open a dialog box, there are these all files, then star.star. That means it is going to open all the files with all the extension types. File types, we can specify what are the file types that we want to open. In my case, I just specified all files with any kind of file name and any kind of extension. And this comes from this FD box. Now we have to import this functionality. FD box, currently we don't have that. So but that is there in Python. FD box. That is where we have to add that functionality. At the very top, we are going to add that functionality. Now we are importing sys, importing TensorFlow. Okay, model from JSON, load model, a bunch of them. And you can see here, import tkinter.file dialog as FD box. Now this is, what is import? tkinter.file dialog. That we have to import. And we give it the name FD box. Now it is connected to this one. Okay, now if we save it, now if we save this thing, it will open as a dialog box. And whatever we select, whatever the file we select, that file name will be inserted into our entry. Entry means you have that text entry box. It will be typed in the text entry box. Okay, now we will see. We will see. You will understand when I say it. Okay. Now we have to save this. Did we save this? No, we didn't save this. So we save it now. Now it is importing all those things. Okay, now you can see what will happen. Now this is the text entry box. Actually, I forgot to do one more thing. Okay, I'm sorry. Now it is, everything is here. It's all good, but we have to connect this function with the button. We have to connect this function with the button. Now this is the button here. It says button one, and it has the text browse for image. Now how do we connect it? How do we connect that function with the button? This is how we connect it. We have to say command equals the function name. Command assign function name. What is the function name? The function name is load image. So we are going to paste it here. Now this button is connected with this function. When I click this button, it is going to call this function. It's going to call this function, and then it is going to open a dialog box. I will select the image I want, and then it is going to put that path to that image in this entry box. Then at the same time, it is going to open that image in that canvas, 100 by 100 canvas that I have in the GUI. So I'm going to save this now, and we will run it and see what happens. Now it opened. Now I say browse for image. Now it is going to open this window. Okay, it's going to open that. Now I can just go through any of this directory that I want and select it. Now if I select somewhere, like anywhere, like banana or anywhere, one of these bananas, it's going to appear here now. But we should not click on this button because we didn't add any functionality to this button yet. We only added the functionality for this button. Now you see the path is written in this entry box. Why? Because it says here self entry, whatever the value that it has now, it should be deleted and insert the file name that we select here. Whatever the file name that we select here should be inserted in the text entry box. What is the text entry box? This is the text entry box. It will be entered here. At the same time, this image will be opened as a 100 by 100 image in this canvas here. But this button still, we are not done with this button. Okay. So now we are going to add function to that other button as well. So now I will close this. Now the other button. Now we have to, now the other button is predict. Predict. Now what are we going to do? There is a predict image function here. Now where we have class labels. What are the class labels? We have only 3 classes: apple, banana, orange. Now we created this ABO model trial v2.h5. We created that. After optimization, we save that file. That file we have to give here. Okay. Then whatever the activities that we did for each of our images have to be done to the test image as well. Because we converted the image to a bunch of numbers. We divided by 255. all that has to be done to the test image that we are going to predict as well. Okay. And then it has to calculate. Now here, list of images, NP expand dimensions. Expand dimensions means now, right now we have the images as a 3-dimensional matrix. But this Keras expects list of images. That means list 1, 2 likewise. It's a list of images. So we have to increase the number of dimensions from 3 to 4. That is what we are doing by np.expand dimension, expand dims. We are going to expand the dimensions by 1 more. That is what is done here. Then it is going to run this model.predict, and then list of images will be given as input to this function. Given as input to this function. Okay. Model.predict. Model.predict is a function that is already there in the TensorFlow library. For it to do a prediction, it needs a list of images. Now that image that we have, only 3 dimensions, we increase the number of dimensions and give it as an input to this predict function. Then it is going to predict and give us the results. Okay. Now that results have to be written according to the most probable or most likely result index into that text label that we had at the bottom. Can you remember there's a text label at the bottom? We removed that label so that nothing appears right now. But when it finds the result is either apple, banana, or orange, then it is going to write it to that label box. So all we have to do is just copy from here to here. Copy this thing. Because here it is going to say like, this is an image of, and then whatever the result that we have, class label. It's going to put it here. With the probability, likelihood, that is the probability. So we are going to paste it right here. Okay. Okay. Now we have to save it. Save it. Yeah, we are basically done now. Let's see what happens. I don't know whether there are errors, but let's see if there are errors. Okay. Okay, now we browse for images. Select one, predict. Oh, didn't predict anything. Oh, I forgot to do one more thing, right? I entered this function, but I did not connect it with the button. That I forgot to do now. So I have the function, but I did not connect it to the button. So this one, this one right here, command, this I didn't do. So that has to be done. Okay. Now we should be fine. Let's see what happens. So it says this is an image of banana. Likelihood 1. Now, if you want to browse for another image, see in the background, it is calculating the probabilities. Can you see that? This is 0, 1, 2. 1 is banana. You can see the highest probability is for the index 1. That is why it selected 9.9 into 10 to the power minus 1. That is like 0.9999. That is the probability. That is what it rounded off as 1.00. So we can browse for another image. It gets stuck. Okay. So test, you can now select, let's say an orange. Select some orange. Predict. Says it's an image of orange. Image of orange. Now you can see here 0, 1, 2. Orange is class 2. Probability is 1.00 into, you can see it's 1. Okay, that is how you do it. Now browse for another one. You can say apple. Some apple somewhere, I don't know, like let's say this one. Predict. Says this is an image of apple. Okay. Do you guys get the idea? Hello?
Yes, sir.
Yeah. So I mean, so similarly, you can do a study for level of ripeness. Now this just identifies these 3, but you can say like ripe, moderately ripe. Likewise, you can select the ripeness. Okay. So it's up to you to like develop on this. Now I have shown you the code. I can send you the code and everything. You can even work on this. Use this as a building block on which you can build some more complex things. Okay. So I think our time is up. Do you guys have any questions? Hello? Any questions that you want me to clarify? Anybody? Who was working with that pie chart, did you get it?
Yes, sir. It's okay.
Yeah. So if you guys need, I mean, I will put all this code into like today's yeah, I will just somehow email them to you. Okay. So I will upload I saw that my name has not been added to the sensor evaluation subject, although I have been asked to deliver some lectures. But anyway, I'm going to upload it to the Google Drive and I will send you the links. Okay. So then if you don't have any questions, we can wind up the session. If you have any questions, you are welcome to ask any questions you have. I know this has been like 4 hours now, but I think it was worthwhile and we created something that we can use as some foundation to create more complex things. Okay then guys, yeah, oh, okay, that's a question. Yeah, I will upload the recording. I mean, now it is in like 3-4 pieces, but I will combine them together and I will upload them so that you guys can refer. Okay. Okay, then there's another question. Oh, thank you. Yeah. Okay. Okay then, guys. Have a really good evening and good rest of the day. Okay, I think I have another lecture, one more lecture next week. At this time, we will try to create something really good. I mean, do you have anything in your mind that you want to create? So this is a desktop application. We can create, I don't know, we can even create websites. Okay, if you have any ideas, let me know and we will create something. Okay. Okay, then guys, you guys have a lovely rest of the day. I'm going to hang up now. Okay. Bye.